Okay, thank you for everybody. It's a point that it's calling attention regarding renewables, and I've been in talk with Roy before regarding this new uh, technology. Actually, parts of this concept is it's kind of old because I've seen before power generations in offshore with kind of turbines, but now it's it's gonna get in a new trend, and the basic point is the economics and also how long does it take uh, to use some of the old oil industry facilities offshore to implement this technology. There are several questions for sure, but Roy could explain a little bit and maybe to clarify several points. And one essential question, it is when he thinks this technology could be available for use in some areas. I know, for example, in Brazil, could be very interesting if they could get those facilities offshore in Northeast, like Rio Grande do Norte, Sergipe, where it could provide energy very soon, and it's not far away from shore, so it could be a good startup point to start. And here in some areas of Gulf of Mexico.
Before Roy starts the conversation, if he could, let's say, explain the system itself, I mean, geometry of the system, how the system works could be interesting for people that are listening to us.
Certainly. And then there are two interrelated things. Excipio and myself, I come from a background of 25 years of building structures for offshore oil and gas. And when we started Excipio Energy, we looked into tidal energy, and we looked into wave energy, and we looked into floating wind. We even looked into something called ocean thermal energy conversion, which in Brazilian waters, Brazil actually has more OTEC potential than just about any other country in the world by virtue of the fact that they've got such a long coast with suitable waters. And the other thing that we're doing, because of our expertise in all these different areas, is looking into how to repurpose the oil and gas industry stuff. And all of those things can be reused, and it's a shame to see them decommissioned and removed. In our particular instance, though, by looking at all those individual renewable energy sources, what we discovered is none of them were economically viable on their own. So we designed a system to integrate as many of them as we could into a single floating system. But the economics and the mathematics works as well for fixed systems or for any offshore renewable energy system. If you're going to take the time to build a structure, a large offshore structure, you need to include on it as many options as are suitable for the area that you're in. My particular platform doesn't work in shallow waters, but there are other systems that do. As part of a DOE study that we're doing, we're looking at using wave energy and wind energy combined along with offshore geothermal and ocean thermal energy conversion if the waters are deep enough or you have access to the deep enough waters. And all of those things, you can use existing oil and gas facilities as hubs. In general, they do not make good hosts for the actual systems, but they serve a very useful purpose as the hub to transmit the power to shore or to convert it into hydrogen or to convert it into power to fuel. So all of these things you can do using existing oil and gas structures. Taking it one step further, once you've built a series of offshore structures, because unlike an oil and gas field where you'll have one platform or two platforms, for an offshore renewable energy installation, you're going to have 100 installations or 200 installations. You can use those also as bases for other industries, whether it's ocean mining, whether it's aquaculture if it's in the shallow waters. There's a whole blue economy that opens up when you start to convert these assets from single-use oil and gas. And also because of the safety aspects, there's lots of industries that can come and access these areas that wouldn't be allowed on an oil and gas platform, for example. Now, our platform in particular, we combine, the one that you see behind me, combines wind, wave, ocean currents, and ocean thermal energy conversion into a single platform.
That's a good point.
And you would get about 4 times as much energy per platform off the coast of Brazil as you would as just a floating wind platform.
Yeah, but in detail, so you install a system in a platform, in an offshore platform, deep water platform, so that you can capture energy source from several sources and concentrate to use in the platform's, let's see, utilization and to export this energy to. So a little bit about this flow of energy, please.
Well, in the short term, this is exactly what like Equinor is doing in Norway. They're putting in a Tampen wind farm to totally electrify their oil and gas production on one of their platforms. Eventually, their goal is to have all of their offshore oil and gas platforms not be burning any hydrocarbons for their power. They're going to either get power from shore from their hydropower, of which Norway has a lot, or they're going to get it from floating wind farms if it's not convenient to tie into shore. We're looking at doing that in the Gulf of Mexico as well. The good news on that part, especially for the startup technologies, is that the price point for the energy that you generate is higher than what you would get if you were selling, for example, into the grid in Rio de Janeiro versus what you could sell to Petrobras to run a platform. There are also ways to reuse the existing pipelines to export the energy. You don't have to export the energy as electrons. You can also just basically pump water through those pipelines and run a turbine at the other end, and then just discharge the water back into the ocean. That's one option. You can do it into pump storage if you want something that's going to be long term. Yeah. The advantage of having multiple systems is that your requirement for energy storage goes way down because you have a much higher capacity factor and a much more constant supply of power.
Yeah. Let me ask you, what amount of energy do you can receive from this system? I mean, in terms of watts or something like that.
One of my platforms, as is designed behind me, would generate about 40 megawatts of power offshore Brazil and have a capacity factor. Capacity factor is how much of the rated power you actually get out on average over the year. For an onshore wind farm, that tends to be somewhere in the 30% to 40% range at best. Solar is typically anywhere from 12 to 25%. Whereas for these floating offshore platforms, a capacity factor between 70 and 85% is probably more realistic. And the ocean thermal energy conversion is actually a base load power. It's 24/7, just keeps going. By itself, it's not economic to do an ocean thermal energy conversion project. But if you can attach it to the floating wind and the rest, you share those capital costs. And so the cost of installation and the mooring and all that is divided up among all the energy sources. And the result is you end up with more power for less cost.
Well, first, I would like a clarification from Roy regarding why your system does not work in shallow water. And you mean shallow water? What is the water depth? You know, we have fixed platform in areas with 100 meters or 200 meters of water depth, which in terms of English is going to be around 600 to 700 feet.
Yeah.
And why it doesn't work in some of those points? Because that could make a big difference in the economics.
For my particular system, as it's designed behind me, the water depth of about 100 meters is required. Oh, okay. So when I say shallow water, you're forgetting that this is actually designed around the Gulf of Mexico, and shallow water in the Gulf of Mexico is more like 120 feet. Okay. So, but anything over 100 meters and it's as designed, it would work fine. If it's shallower than that, we can modify the design, but the whole point is to try not to modify the design. We've designed it so it will work the same exact hull would be used in Brazil as would be used in the North Sea, as would be used off the coast of Japan, because that way you can mass produce the hulls. You don't need to customize them. Some of the other floating wind only designs out there are like that. They have to be modified depending on where they're at. The other caution is when you look at some of the resource data is the equivalent of oil and gas prospecting, where you're looking for the reservoir. Some of the resource data doesn't recognize the advantages of integrating different systems together. If you look at the coast, if you look offshore Brazil, the wave resource looks rather low. But what that leaves out is that it's a 2-meter swell all the time. I mean, you and I both know that's why there's no spars in Brazil, because you can't do a float over, because if you don't get less than a 1-meter swell, you can't do a float over. So it may not be a big amount of energy per wave, but if it's constant and it's 20, you can design a system that captures that, and your capacity factor then is in the high 80s. I mean, you're all the time. You don't need the energy, you don't need the battery storage that you would normally need on shore. So all of those things need to be taken into account when you're looking at the resource. In the Gulf of Mexico, for example, the BOEM report that came out, they show a very good wave resource, but then when they made this caveat that there's nothing in there that's economically recoverable. And on its own, there are very few wave energy devices that work by themselves, enough to pay for themselves. Of the 500 or so in our database, I know of 2 that can be commercial if you deploy them. And so for them to say that is an arbitrary number. And if you take the installation and things out of that by combining it with another platform, then all of a sudden the economics work. There are other systems, there are other ways to build a system like mine for shallow water. We're focused on the deep water. As far as the amount of power it makes, that 30 megawatts, that was actually sized to be sufficient to power a subsea tieback to tie back to oil and gas platforms if they wanted to use it to develop, say, contingent reserves, or if you wanted to set up a series of pump stations to take stuff to shore and skip the FPSO entirely.
Good. And which companies are using these systems nowadays?
Well, Equinor is the only one actively installing offshore wind to support their oil and gas facilities. Shell and BP are looking at doing the same. Exxon, to my knowledge, is not looking at it at all. Petrobras has been talking about it, but I don't know that they have any plans to do so. They may, because Equinor may bring some of their stuff down there to Brazil through the fields that they are participating in. Certainly, Brazil has had a lot of interest in the offshore renewable space lately. And then this idea of repurposing the platforms, one thing people always ask, can you put a wind turbine on a platform? And the answer is generally no. The loads are very, very different. However, you can put the substation, or you can put the hydrogen production, or you can put a power to fuel. There's all kinds of things you can put on the platform that are useful. And also you've got all those tiebacks they already have for exporting whatever it is they're making. And that's where a lot of the value comes in. And so it's a waste of capital and of resources and of, it adds to the carbon load to rip those things out and then build a new one. It makes no sense.
I'm not sure in terms of the megawatt, what the market's paying in Brazil, if you can make economically this project essentially in Brazil, because there are several components there. Mm-hmm. The local taxes, several points. One point that I'm curious to know, if you use some of the old offshore facilities, how IBAMA and the Navy will deal with that point, because there are there are old facilities, but the facilities are there, and there are liabilities from the oil operators. So how do you think that you can make those things work and avoid? I'm talking about seeing this as an investor view. Mm-hmm. put some money or not. And that is one point that concerns a lot of people.
And I understand why. And certainly I'm far more familiar with the Gulf of Mexico rules and and we had the same issue with Bessie here. You have very strong decommissioning requirements. You have end of life requirements that you have to meet. There has been a willingness, certainly on the part of the leasing, the BOEM agency, to repurpose these platforms. In fact, the regulations in the U.S. directly allow for that. If you go look into CFR 3585J, you can repurpose an offshore oil and gas platform to a renewable energy center. And once you've done that, then the decommissioning kind of gets deferred as long as it's still being used for that purpose, and as long as the lease is still valid. The issue only is with the ones that were already on the decommissioning list. If they're not producing anymore, then that becomes the gray area in the U.S. And that's where you get pushback from Bessie, the enforcement agency. So we have that same issue here. In Brazil, I don't know how strongly they look at it. It's actually environmentally sound to leave the platforms. Now, they still have a requirement in the U.S. to P&A the wells if the wells are done. However, there's also a company called Serify that we're working with right now that is looking to re-enter those old oil and gas wells and convert them into geothermal power. So you can even add that to the mix, and that just adds another layer of revenue stream and power. In places where the electricity market doesn't support the price required for platforms like this, and that's like, for example, the Gulf of Mexico, one of the things we've identified is there's a whole lot of value-added products that you can produce off of these platforms that don't necessarily involve selling electrons directly. You use the electrons to do something else, whether it's making the green hydrogen, which also involves making green oxygen. You have to go away from a single commodity mindset if you want to work in offshore renewables. You can't. That's not drilling a hole and money comes out, which is what oil and gas is. It has to be, you have to look for, this is going to feed into that. This is my waste stream. What can I use it for? Where does it feed in? If I put a fish farm, I can percolate the oxygen through, for example, and it cuts down the parasites and speeds up the fish growth. If I'm doing OTEC, I can take that water and feed it into an algae or crustaceans, and they love it. They think it's great. Lots of food. There's all kinds of ways you can feed one thing into the other to make all of them better, and all of them have more value for the products they export. In some places, water is in high demand, clean water. And so you can use that energy to make this, to desalinate water and pump it to shore using the old pipelines once you've cleaned them up. Those pipelines are suitable for water once they've been cleaned, right? You get it down to the ppm levels that's required for your water system, and there you are. So there's lots of different ways to do it, but it's very site and platform and market specific. So there's no generic answer of this is what they all look like. That's why our patent is only around the platform. The platforms are steel islands, and what we put on them, we customize to whatever market we're going to be in. But the platform itself is designed not to change, whether it has OTEC, doesn't have OTEC, whether it's being used for, aquaculture as well as energy production or just energy production. None of those things change the design of the platform.
Good. Okay. I suppose Roy brought to us some good thoughts about the system, the energy system that they can apply to offshore platforms. Very good, Alvaro. Thank you so much for bringing new technologies for our conversation. Thank you, Har.
Thanks for having me.
Thank you.